Now, my topic is Inconsistency of Ampere's Law, which deals with the modification of Maxwell's equation. For that, we can consider the basic laws in electricity and magnetism before Maxwell. We have Gauss's law in differential form, del dot E is equal to rho by epsilon 0, and the magnetic monopole does not exist, that is del dot B is equal to 0, and Faraday's law of induction, del cross E is equal to minus dou B by dou T, and the Ampere's law, del cross B is equal to mu 0 J. When we consider mathematical application across these equations, we get some inconsistency across this equation, Ampere's Circuital Law. To prove that inconsistency of Ampere's Circuital Law, we can consider the two curl equations del cross E and del cross B. Then first take the divergence of del cross E is equal to minus dou by dou T of del dot B. In this equation, we can consider the divergence of a curl of a vector will be equal to 0. And also, according to the previous equations, del dot B also will be equal to 0. So, this equation is consistent with this application. Now, we can consider del cross B is equal to mu 0 J and apply the divergence. Del cross B is equal to mu 0 del dot J. And mathematically, divergence of curl of a vector is 0. So, the LHS will be equal to 0. But as we know, according to continuity equation, del dot J is equal to minus dou rho by dou T. The RHS will not be equal to 0. That means there is some inconsistency in the Ampere's Circuital Law. Our aim is to remove the inconsistency in the Ampere's Circuital Law. So, consider the Gauss's law, del dot E is equal to rho by epsilon 0. From that, rearrange rho is equal to epsilon 0 del dot E. Then we can substitute this rho in the continuity equation. Then del dot J is equal to minus dou rho by dou T equal to dou by dou T of minus epsilon 0 del dot E. Del dot J can be written as del dot minus epsilon 0 dou E by dou T after rearranging. So, divergence is there on the LHS and the RHS, and the similar term on the RHS to J is minus epsilon 0 dou E by dou T. So, the Maxwell suggests that if we add this term on the RHS of the Ampere's Circuital Law, we can remove the inconsistency in that equation. We can check that. To remove that inconsistency, I am going to add epsilon 0 dou E by dou T on the RHS of Ampere's Circuital Law. That is del cross B is equal to mu 0 into J plus epsilon 0 dou E by dou T, which implies del cross B is equal to mu 0 J plus mu 0 epsilon 0 dou E by dou T. Now, we can do as before, apply the divergence on RHS and LHS. That is del cross B is equal to del dot mu 0 J plus mu 0 epsilon 0 dou E by dou T. That is del cross B, LHS will be equal to 0 and the RHS is mu 0 del dot J plus mu 0 del dot epsilon 0 dou E by dou T. Then by substituting Gauss's law in the continuity equation, we already got del dot J is equal to del dot minus epsilon 0 dou E by dou T. Substituting that in this equation, we can write 0 equal to mu 0 del dot minus epsilon 0 dou E by dou T plus mu 0 del dot epsilon 0 dou E by dou T, which implies these two terms are opposite terms, so it will be equal to 0. Thus we got LHS equal to RHS. Hence, remove the inconsistency of Ampere's Circuital Law by adding the term epsilon 0 dou E by dou T. Then, the Maxwell's equations for electromagnetism can be written as del dot E is equal to rho by epsilon 0, which is representing the Gauss's law, and del dot B is equal to 0, which represent the magnetic monopoles does not exist, and del cross E is equal to minus dou B by dou T, which represent Faraday's law of electromagnetic induction, and del cross B is equal to mu 0 J plus mu 0 epsilon 0 dou E by dou T, which represent the modified Ampere Circuital Law. Here, the Maxwell's contribution is epsilon 0 dou E by dou T. Epsilon 0 dou E by dou T equal to dou by dou T of epsilon 0 E, which can be written as dou by dou T of D, where D is the displacement current. And also dou D by dou T is equal to JD, which is the displacement current density. That is D. Displacement current D is the current flow without the motion of charges. So, the current flow without the motion of charges exists when E varies with T. In such a way, by removing the inconsistency of Ampere-Circuital law, Maxwell's term establishes that, according to Faraday's law, the change in magnetic field induces an electric field, and according to modified Ampere-Circuital law, the change in electric field induces a magnetic field. Thanks for watching. Subscribe my channel for watching more videos.